Another kind of coverage that we might look for is going to be inspired by what happens after we fix this exfer function. And so the likely fix for the bug that we had in this exfer function is to lock both of the bank accounts that we're processing, transfer the balance between them, and then unlock the accounts. And what this will do is make sure that no other threads in the system are messing with the two accounts that we're updating while we're in the middle of messing with them. Now, one thing that people have found is that while testing concurrent software is that it's often the case that you can delete all of the locks out of the code, run it through some tests, and often it passes. And this is really sort of a scary and depressing thing, because what this means is that during the test suite, the locks weren't doing anything. This has inspired a test coverage metric called synchronization coverage. What synchronization coverage is going to do is ensure that during testing, this lock actually does something. In other words, during testing, the exfer function is going to be called to transfer money between accounts when the accounts are already locked. And what this does is ensure that we're stressing the system to a level that the synchronization code is actually firing, is actually having some effect on the execution. And if that's happening, what that means is we're probably doing a reasonable job stress testing the system. So that was really quick. And like I said, we're not going to get into this in detail. In summary, if we're testing concurrent software, we want to be looking at concurrency-specific coverage metrics, such as interleaving coverage, which meant, if you recall, functions which access shared data are actually called in a truly concurrent fashion, that is by multiple threads at the same time. And also synchronization coverage, which ensures that the locks that we put into our code actually do something.